need to charge these after this. So we're going to go on and start going over this today. Since normally, given missed days or whatnot, things get backed up, I would normally let y'all work on this today. Need to hit record. We're going to work about halfway through this here, and then we'll finish it up on Monday. Because again, I don't like trying to put tests on Mondays if we can avoid it. So we're going to do half of it today, half of it Monday, and then your test will be Tuesday. Try to get any of the assignments you're missing in if you can. Not if you can't, please get them in. Y'all don't need zeros this late in the semester. So the first thing we're looking at is this here, problems 1 through 5. Evaluate each expressions for -2 and 3. And I think these are some of the ones that you like the most out of all of them. Because we can look at, say, number 2, 7 times 2 to the x minus 3. Well, for -2, we would say, oh, I need a pen. 7 times 2 to the -2 minus 3. Well, in the calculator, we can say 7 times 2 to the -2 minus 3. -1.25. So for these here, we just have to type them into the calculator. I'm going to need a review sheet because I can't remember the problems half the time. So for this one here, and that's half of it. So all we had to do is type it into the calculator. It gave us our answer, and we're partway done. Well, the reason we're partway done is we also have to do it when x is 3. So we're plugging x as -2 in first, and then plugging it in as 3. So we can say 7 times 2 to the 3rd minus 3. And we get 53. Questions on these here? We kind of like these. Just got to plug the number in for x, then type the whole thing in the calculator, and we're done. And with any of the ones that have it evaluating, either these or the ones we'll see later, logarithms, just type it in exactly as you see it. However it's written, just type it in that way. Do we need to see another one of these here? Feel comfortable with these here? All right. 6 through 11, determine whether each of the following is exponential growth or exponential decay. Well, for the first set here, for 6 through 8, we determined if it's growth, if b is greater than 1. And it's decay if b is between 0 and 1. So if the value of b is between 0 and 1, it's decay, and if it's greater than 1, it's growth. And well, it's probably nice to see that y is equal to b to the x is the general equation. We can probably do all 6 of these pretty easily. So looking at number 6, y equals 7/6 to the x. Would this be growth or decay? Growth, because the numerator is bigger, which means it's greater than 1. So this would be growth. How about number 7? Decay. Because 0.9 is less than 1. And the last one, 7.9, growth. And that's all we have to do for 6 through 8. Now, 9 through 11 is a little bit different. We considered it growth if the exponent was positive. It's decay if the exponent is negative. Sure. You can take a seat if you want. There you go. So for these here, it really doesn't matter what's in front of it. It's more about the exponent. So number 9, would it be growth or decay? Growth, because the exponent is positive. Number 10 would be decay. Exponent's negative. And the last one, growth. Even though it is 9/10, it's still positive, so it's going to be growth. Questions on any of this here? All right, 12 through 19. Rewrite each equation from logarithmic to exponential form. Now, the way we went over this first was we stated that log base b of x is equal to y if and only if b to the y is equal to x. And we went through switching it from one form to the other, and a lot of it just seemed like a whole bunch of magic that we can switch from one to the other, and it worked just fine. So, number 12, log base 9 of 6,561 equals 4 would rewrite as what? To the 6,561, yes? Well, if I put 9 to the log base 9, what do we know with that 9 and log base 9? They cancel out, yes? So this would cancel out, leaving us with what? 6,561. What I do to one side, I have to do to the, so it'd be 9 to the 4th equals. So what we did for solving, we could actually do here and change it from logarithmic to exponential. We don't have to just use this here. It's the same method. So we can do 5 and 5. Those are gone. 7, 8, 1, 2, 5 equals 5 to the. It'd been nice if we went over it that way first, isn't it? But that's the same method as what we're doing with this here. We just hadn't gone over the fact that putting both sides to that base as the same as what the base is cancel out. Both work. So 14, I could put both sides to the 1/7. Those are gone. 2,401 is equal to 1/7, put parentheses, to the negative 4. Well, we've already done them all so far. So 15 would be 15 to the first is equal to. And the nice thing with these here, with exponentials, we can actually check them if we wanted to. Because if I wanted to type in 1/7 to the negative 4th, hit enter, it should give me 2,401. I can check these. We can plug them in and check them to make sure we have them set up correctly. Any questions on 12 through 15? Let's see what 16 through 19 are. Okay, 16 through 19 is dealing with our natural logs. And the natural log formula that we had when we started this was that ln of x equals y, if and only if e to the y equals x, yes? Well, when we solved these recently, I would put both sides to the e. Well, e and ln tell me x is equal to, that's it. It's an exponential form. Because it's the same thing. Ln of x equals y. Well, here x is actually x. Y is 7. So e to the 7 equals x. It's the same method. We just actually have the basis for why it works. Any other questions on this here? So what would 18 be? 71 equals e to the y. That's all we have to do on these here. Now, if you notice, all four of these have a variable somewhere in it. Because what did we realize with natural logs? We don't get nice numbers coming out of them or equal to it. Yes. Yeah, I use x and y because so that we can actually get something closer to a true statement. Because e to the ninth we already know is a pretty ugly number. Anything e to any power is not a nice number. So there's no way to make it be a true statement without approximating. Any questions on these here? Rewrite each equation in logarithmic form. So we can go the other way around, flipping them back with the base. So looking at 20, we can say it's log base 3 of 81 equals 4. Well, when we solve these, what did we do? Well, to get rid of the exponent, we could say log base 3. If it'll let me, there we go. Log base 3 of both sides. Well, log base 3 of 3 to the 4th is just, well, 4, because the exponent of 4 moves out front. Log base 3 of 3 is 1 equals now it's in logarithmic form. So we can do the switch method. If y'all are more comfortable with that, do that. But if this makes sense, we're trying to get it back into logarithmic form. The only place there's an exponent is 3 to the 4th. Log base 3 of both sides. So what would we do about 21? Log base what? 1/5 of 1 over 125 equals, let me get a little more space. So 1/5 to the third power is equal to 1 over 125. Now, if we wanted to work it out, I could say log base 1/5 of 1/5 to the third equals log base 1/5 of 1 over 5. 3 moves out front. And log base 1/5 of 1/5 is? Make more sense? But that's all we're having to do, because we could do the little bit of the switch method that we've done before. That works just fine. Or you can look at it this way here. Either way still gets you to the same answer. Any other questions on these first three? So sorry, what would the 22 be? Log. Almost. Equals thirds. Because the log base, yeah, it's so many things are moving, and that's fine. Because the log, we're trying to get this out of exponential, so this exponent really has to come away. So we're doing the base at 125 of what it's equal to the power. Because our y goes to what it's equal to, x goes inside the log, and that's going to be our base. So if using that method of switching makes more sense for these here, do that. Because if that, what we just showed a minute ago, is confusing, don't mess with it. So any other questions on 20 through 22? 23 through 25. E to the 4th equals x. Yes. Because we can apply ln to both sides, and ln of e is 1. As the 4 moves out front, and that becomes 1. So we just left with 4, and the other side's ln of x. How about 24? Any other questions on these here? alpha is going to be 35. Yes. So it is a little bit longer, but there are a good number of problems like these, the exponential growth, and the changing from exponential to logarithmic. Questions on these here? Yeah. So we can look at 26. My review sheet back. Yes. So here, for log base 5 of 1 over 125, math, we can go over to log base 5 of alpha y equals enter 1 over 125 and hit enter. -3. Also, if you're hearing that beeping noise, it's coming from the headset. It's trying to notify me that the batteries are about to die soon. So, plug it in when we get -3. Wasn't that also one of the rewriting from logarithmic to exponential? Or exponent, yeah. One that we had earlier, or close to it. Yeah, 21 was close to it. It's just 5 instead of -3. Or it was 3 instead of -3. So 31, ln of 4 to the 6th. So I would type it in exactly as it has it. So ln of 4 to the 6th. Well, helpful if that parenthesis was not in the exponent. Third. Yep. 318. Yep. So it'll say in the directions 3 decimal places. And if it doesn't specify, just ask. I will specify for it. So do we like these here? All right, 32 through 35, expand the logarithms. How many of y'all dislike these? Yes? Okay, they're not, those aren't on the test and neither are condensing. Yeah. It's not that so much that they were difficult, they were just very time consuming and making sure we did the process right. So I'm not going to mess with them. So the rest of this is all dealing with solving. We'll look at these two here, or look at one of these. We'll save the other one for Tuesday. Not Tuesday, Monday. And then do one more with solving. So we can look at number 40 today. We'll look at 41 on Monday. These here, 2 to the 2x plus 15 equals 8 to the x minus 7. Most likely, if we have variables on both sides in the exponents, this is going to be one of the ones that I called the one-to-one property. The book called it something different. But what we're trying to do to start with is to get these two numbers to be the same. Well, 2 is as simplified as it gets. But we can rewrite 8 as 2 to a power. Because 2 times itself a certain number of times would be 8. And that would be 3. Because 2 times 2 is 4 times 2 would give us 8. And we can distribute 2 to the 2x plus 15 equals 2. Well, 3 times x is 3x minus 3 times 7 is 21. Now, according to what I call the one-to-one property, well, if the bases are the same, there's no way we can change the 2's. If they're the same, well, apparently it's going to scroll. The exponents have to be also. If the bases are the same, the exponents have to be the same as well. So that tells us that 2x plus 15 has to equal 3x minus 21. Now we just need to solve for the value of x. Be good if I get off. So what can we do first? We can do both. Not at the same time, but so subtracting 2x would work, or we can add 21. So I'll add 21 here. And if we add 21 to both sides, we get that 2x plus 36 is equal to 30x. Then we have to subtract 2x from both sides, telling us x is equal to 36. And I feel like we got the same thing, yes? So we can go either way and get to the same answer. Now, we don't have to worry about restrictions because, again, the x is in the exponents. Because whenever the variable is in the exponents, it can be positive, negative, or 0. The only ones we have to worry about is whenever it's going back into the logarithms. Those cannot be 0 or negative. Any other questions on 40? Still good with 40? All right. We'll look at one more today. We'll save, well, we can do 42 if you all want. Well, the bases are already the same, aren't they? So that means 4x plus 7 has to equal 6x minus 35. And that's how we went through this the first time around, yes? Well, one of the methods we learned later on was if I want to get the exponent out, we would apply whatever logarithm to it, yes? Here it's e. So if I applied the natural log to both sides, ln of e is gone, ln of e is gone. It tells us that 4x plus 7 equals 6x minus 35. That's why this works. Now we just need to solve. Well, we can do several things. I'll subtract 4x from both sides, which tells me that 7 is equal to 2x minus 35. $42. X equals 21. Any other questions on any of this here? So, with how this is broken up, we'll go on and stop here. We'll finish up the rest of the solving on Monday. That way it'll be a little bit fresher.